Hi and welcome to Subnet Analysis Part 2. This video looks at hosts, their IP addresses and masks, and their default gateways, particularly the routers that act as their default gateways. This video is not geared toward figuring out how to do subnetting math. Instead, once you know subnetting math, this video helps you understand how to apply that math to different scenarios on the Cisco exams. First, consider the LAN interface of a router acting as a default gateway, like router R2 here in this picture. We assign it an IP address and we assign it a mask. Then consider the host. It is also assigned an IP address and mask, but that mechanism is completely independent from the assignment of R2's address. That is, the host address could be anything, the mask could be anything, and they could disagree. Also, the host needs to be assigned a gateway IP address that should point to the router's IP address. However, it's perfectly legal and possible to assign the wrong number, to point to the wrong IP address. So the first and simplest thing to think about when thinking about the hosts and their gateways is to make sure that the host gateway setting is actually equal to the IP address really used by the router in this case. For instance, if I give host D on the bottom right an address of 10.1.4.1, and we give router 4's LAN interface 10.1.4.254, D's gateway setting ought to point to that 4.254 address that we see up next to router 4. Easy to check if the information is there. Now, the more complicated part of this is that the host and the router may differ in their opinion about what the subnet is that they're both attached to. Remember, both the router and host set their IP addresses independently of each other. In other words, the mechanisms are different. So what do we need to do? We need to look at both the router and host and think about the subnet. Now, the subnet itself is comprised of a subnet ID and a range of addresses. Now, this information, though, can be calculated. It can be calculated based on the IP address and mask of the router, and it can be calculated based on the IP address and mask of the host. So the question is, do they agree? Is it the exact same subnet that both the router and host believe exists on this LAN? For example, continuing to look at router R4, if we take R4's IP address 10.1.4.254 and then consider that the engineer chose a mask of /24, or if you prefer 255.255.255.0. If we do the math based on that IP address and mask, you see that the subnet ID is 10.1.4.0, the broadcast address then at the bottom is 10.1.4.255, and the range of addresses in that subnet are the numbers in between there. Low end range, .1 as you see here in the last octet, and .254 in the last octet. Now if we do that same mask there on host D with IP address 10.1.4.1, also with mask /24, then you're going to come up with the same answer. Subnet ID ends in .0, first address .1, last address .254, and the broadcast address of .255. Now if either the router or host used a different mask than the other, then by definition it's not the exact same subnet. So that's an easy thing to check. But if they're using the same masks, it's useful to do the math to make sure. For instance, let's say instead of /24 in this case, both R4 and host D used the same IP addresses, but they used a mask of /25. Well, if we repeat the math, we'd see that per the router, the subnet ID is actually .128, and the first address is .129, as you see here. That's a different subnet, which you'd expect because we're using a different mask than the previous example. The host, with address 10.1.4.1, also with mask /25, ends up in a subnet with subnet ID 10.1.4.0, first address .1, last address in this case though is .126, with a broadcast address ending in .127. So indeed, host D and router R4 differ in their opinion about the subnet. So that's not going to work very well. For instance, router 4 forms its connected route for that LAN subnet based on its IP address and mask. So R4's route to that connected subnet where host D exists thinks that the range of addresses is .129 through .254. In other words, R4 doesn't have a route that matches host D's IP address. When R4 advertises routes to the other three routers, they'll learn routes, but that route won't match host D's IP address. It's not in the same range. As it turns out with this particular mistake, host D cannot communicate anywhere off subnet because R4 and the rest of the routers don't have a route that matches D's IP address. In summary, when thinking about hosts and their default gateways, you want to make sure that the host gateway setting is equal to the actual router's IP address on that LAN, and you want to check the router and host IP address and mask combos to see if they agree as to what the subnet is.